All right, so let's start. All right, it's January 2017, CSEC past paper. All right, so you got about 15 or 20 minutes. They normally give you about a minute and 10 seconds to attempt each question at the CSEC level. You have about a minute and 10 seconds to attempt each and every question. All right, you have 60 questions and they normally give you an hour and 15 minutes. And you have about 10 minutes reading time in all of that. So let's start with the first question. In which of the following situations is Brownian motion demonstrated? So if we try to remember what Brownian motion is, Brownian motion is a method that came into existence because of the man Robert Brown. Robert Brown, the man who had nothing to do in his apartment while he watched the dust particles stream into his room in the morning sunlight, and he noticed that the dust particles were moving in random motion. And he concluded that the dust particles were being constantly bombarded by air particles. So we're looking for something that is speaking of bombardment or random movement. So let's see. A says pollen grains moving at random in water. Okay, A seems to be the most likely answer so far. The scent of perfume moving from one part of a room to another, no, that's diffusion. The swelling of red beans when soaked in water, that's osmosis. The loss of heat from a hot body to a cold body, that have nothing to do with it. The answer is A as in apple. All right, so the answer for question 1 is A as in apple. Pollen grains moving at random in water. All right, that reflects Brownian motion. Question 2. Item 2 refers to 4 sets of properties represented by options A, B, C, and D below. You have the relative charge and the approximate mass. The question asks you, which of the properties above refer to a neutron? Now, a neutron is neither positively charged nor negatively charged. A neutron is neutral, right? So we're looking for something where the charge is 0 and the mass of a neutron is 1. So we're looking for something that has a charge of 0 and approximate mass of 1. So that looks like B. B is your answer. Relative charge 0, approximate mass 1. B as in boy is the answer for question 2. All right, so question 3. So the first things first, I want you to know that this question, I don't expect you to know all the things about this element, the compound, whatever that they're dealing with here. I don't expect you to know everything about it. However, I expect you to apply your understanding of the elements to the question. So from the table below, which of the substances represented by the options A, B, C, and D is most likely sodium chloride? Now, salt, which is sodium chloride, ask yourself, does salt conduct electricity? If you take salt that you sprinkle on your avocado, will it conduct electricity if you were to stick 2 poles, a positive and a negative, inside of it in its solid state? And the answer to that is no. It will not conduct electricity in its solid state. However, if you were to add water to that and dissolve the salt particles, then it possibly could conduct electricity. So now that we know that, we can check our options and see which of them corresponds to solid state as no, it does not conduct electricity, but in the aqueous or liquefied state, it does conduct electricity. So our options are A, no for the solid state, yes for the aqueous state, and D, no for the solid state, yes for the aqueous state. Now, the next thing now, we need to figure out what is the boiling point. Ask yourself this question. If we have water and water boils at 100 degrees Celsius, when we add salt to it, the boiling point raises above 100 degrees Celsius. Now, minus 35 means we are below zero, means that's freezing, all right? Below zero is getting colder. So we're talking about something that is ice. So the boiling point of sodium chloride has to be above 100 degrees Celsius. So the most likely answer is A as in apple, 1465 degrees Celsius. No, it does not conduct electricity in the solid state, but yes, it conducts electricity in the aqueous state. All right, so I did not expect you to know all those facts, but I wanted you to be able to figure it out based on your knowledge and the information that was provided to you. You can logically figure out what the answer is. Here's an apple. All right, so next question. Which of the following compounds is soluble in cold water? Now, we have to ask ourselves a couple of things. How do we know which one to choose? So we have to go back to different salts. We have nitrates, sulfates, we have chlorides, bromides, iodides. All nitrates are soluble. There are no insoluble nitrates. That's the first thing we have to know. Most sulfates are soluble. However, lead sulfate is insoluble, barium sulfate is insoluble, and calcium sulfate is insoluble in water. Most chlorides, bromides, and iodides are soluble in water. However, silver chloride, silver bromide, silver iodide, lead chloride, lead bromide, and lead iodide are insoluble. All the other chlorides, bromides, and iodides are soluble. So the next thing is the carbonates. Sodium carbonate is soluble, potassium carbonate is soluble, and ammonium carbonate is soluble. Most other carbonates are insoluble. Hydroxides, sodium hydroxide is soluble, potassium hydroxide is soluble, and ammonium hydroxide is soluble. Most other hydroxides are insoluble. So that there is basically the theory as it relates to the information that is placed before us. That's what we would have learned, right? So let me see if I could pull up a table with that information for you. Yes, so your nitrates, here we have the nitrates. Most nitrates are soluble, right? Most nitrates are soluble. Most sulfates are soluble. Most chlorides, bromides, and iodides are soluble. Sodium hydroxide, potassium hydroxide, ammonium hydroxide, these are all soluble. Sodium carbonate, potassium carbonate, ammonium carbonate, these are all soluble. So the ones that are insoluble, you have the lead sulfate, lead chloride, lead bromide, lead iodide. These are all insoluble. All right, so let's go back to the question now. And the question says, which of the following compounds is soluble in cold water? You have lead sulfate, lead nitrate, lead chloride, and lead carbonate. All right, so our answer is B as in boy. Lead nitrate is soluble in water. All right, lead nitrate is soluble in cold water. All right, moving on. Next question. Which of the following oxides show both acidic and basic properties? Which of the following oxides show both acidic and basic properties? So, to answer this question, we need to try to remember if something is exhibiting acidic properties and basic properties at the same time, that substance is said to be amphoteric, the ability to act as an acid as well as a base. So I want you to recall some information in the first couple of classes I would have taught you, we would have come across this. Reacting with acids and alkalis, they tend to produce salts. But if we have aluminum oxide and react that with hydrochloric acid, it would produce aluminum chloride. Aluminum oxide in this instance is acting as a base, right? The hydrochloric acid is acting as the acid. So in the first instance, the aluminum oxide here is acting as a base, right? Because we have an acid, and because the hydrochloric acid is more acidic than the aluminum oxide acts as the base, right? So in this instance, aluminum oxide is acting as a base. In the second instance, aluminum oxide is being reacted with sodium hydroxide. Sodium hydroxide is a base, right? Sodium hydroxide is a base. So therefore, aluminum oxide is going to act as an acid to react with the base. So in the second instance, it is acting as an acid to react with the base to give you sodium aluminate plus water. So in one instance, it's acting as an acid, and in the next instance, it's acting as a base. This just simply tells us that the aluminum oxide has the ability to act as both an acid and a base. So let's go back to the question. Which of the following oxides shows both acidic and basic properties? And based on that, it would lead us to this option. D as in dog, aluminum oxide has the ability to act as both an acid and a base. Aluminum oxide is your answer. D as in dog. All right, next question. Which of the following statements best describe the difference between an atom and an ion? So again, before we answer the question, I have some information that we have to recall. So what information we need to know in order to do this question? Ions could be positively charged. Ions could be negatively charged. An ion is an atom that has a charge on it, right? It means to say that the atom either would have lost electrons or would have gained electrons to either become positively charged or negatively charged. So let's go back to the question. Which of the following statements best describe the difference between an atom and an ion? So let's see the first option. The first option says an atom is electrically neutral. This part is correct. But an ion is positively charged. But an ion could also be negatively charged. So this first part, A, only considers positive ions, but it doesn't consider negative ions. So A cannot be our option. B, an atom is electrically neutral. Okay, true. But an ion is negatively charged. This part B considers the negative option, but it does not consider positively charged ions. So again, B is not our answer. So let's try C. An atom contains equal number of protons and electrons, whereas ions contain more electrons than protons. Okay, so not necessarily more. This word more here is question. It don't necessarily have to be more, it could be less. D, an atom contains equal number of protons and electrons, yes. Whereas an ion contains unequal number of protons and electrons. D seems like the most likely answer. D seems like a most viable answer in this question. Yes? D as in dog. So let's see what answer we come up with. Yep, D is the answer. An atom contains equal number of protons and electrons, whereas an ion contains unequal number of protons and electrons. All right, so moving on to the next question. What type of reaction does the equation represent? They ask you, what type of reaction does this equation represent? On this side here, we have an alkene. All right. And on this side, we have a halogeno alkane. All right. We have a halogeno alkane. So it means to say that a halogen, chlorine, has been added on to the alkene. How did that happen? So that means we have to go back a little bit to the theory before we come back to answer this question. So when we consider addition reaction, what is an addition reaction? Addition reaction occurs when two reactants combine to form a single new product with no atoms left over. So in general, addition reactions, the double bond is broken. So there's a pi bond and a sigma bond. The pi bond, which is the weaker of the two, is broken. And then we have the formation of two sigma bonds here. All right. So whatever the substance is, X and Y here, it's now added across the double bond. And this is considered an addition reaction. Now, to add something onto means you have, let's say you have 5 chairs and you come and you add a 6th chair. So you have 6 chairs instead of 5 chairs. If we have an addition reaction, if we had 4 bonds, to add something onto it, it means to say that something would have been broken and we'd have add an extra bond or extra 2 bonds onto that structure. So let's go back to the question. That's the first thing. Substitution reactions. With substitution, it means to say something is taking the place of something else. So, for example, let's say you are sitting down in your seat and I want to substitute you. I can come and remove you from your seat and take your seat. You have been substituted. If you're playing football and the coach see like you're not playing well enough, the coach would call you off the field and let somebody else take your place. You have been substituted. If you're playing basketball, there's supposed to be 5 players on the court, and the coach see like you're not doing so well or you need to give you a rest, the coach would call you off, and then when you're called off, somebody else takes your place. That is substitution. You are being substituted. So when we have a substitution reaction, one element is being replaced by another element. One functional group is being replaced by another group. When we have addition polymerization, first we must have a polymer. What is a polymer? A polymer is made up of many monomers. Now, if we have addition polymerization, it means to say that we had an alkene of some kind, right? Sorry. We had an alkene of some kind, and the double bond in the alkene was broken to give us the alkane repeated unit. When we get this alkane repeated unit, the type of polymerization we will have would be addition polymerization, because this double bond here was broken. If we have condensation polymerization, it means to say that the polymer alone is not produced, but the polymer along with another molecule is produced. So what type of reaction does the equation represent? If we look at it closely, we recognize that this bond here has been broken, and chlorine 2, Cl, Cl, one chlorine has been added on this side, and the next chlorine has been added on the next side to give you Cl bonded here and Cl bonded there. So that is a addition reaction. So they ask you, what type of reaction does it represent? It represents an addition reaction. Right? Addition reaction is your answer, and that's supposed to be A. I have C there, that should be A. A as an apple. This is your answer. A as in apple is the correct answer. All right, so next question. Which of the following is classified as a neutral oxide? Which of the following is classified as a neutral oxide? So we have acidic oxides, we have basic oxides, and we have neutral oxides. So let's remind ourselves what a neutral oxide is. Non-metals that form oxides that show neither basic nor acidic properties. A neutral oxide is formed by non-metals that form oxides. Now, an oxide is basically a non-metal, for example, carbon, and it has oxygen attached to it, and that will give you the oxide of the non-metal. So non-metals that form oxides, and these oxides does not show acidic properties or basic properties. The next property about it, they tend to be insoluble in water. So, examples of neutral oxides. Water is an example of a neutral oxide. Carbon monoxide is an example of a neutral oxide. Nitric oxide or nitrous oxide or nitrogen oxide is another example of a neutral oxide. So let's go back to the question and see what options they gave us. Which of the following is classified as a neutral oxide? Sodium is a metal. Sodium oxide is a basic oxide because we deal with a metal. So this is not a neutral oxide. Sulfur dioxide. Sulfur is it will fall under the non-metal category, and this is an acidic oxide. Carbon dioxide. Carbon dioxide is also acidic oxide, but carbon monoxide is a neutral oxide. So the answer to this question is D as in dog, carbon monoxide. Carbon monoxide is your neutral oxide. All right, next question. An element X has an electronic configuration of 281. An element X has an electronic configuration of 281. At which of the following positions is the element in the periodic table? Now, in order for us to figure out which period that this element belongs in, we need to check and see how many shells it has. So this is the first shell. The first shell holds 2 electrons. The second shell holds 8 electrons. And the third shell holds 1 electron. So that means to say that there are 3 periods, 2, 8, and 1. There's 1, 2, 3 shells, right? We have 3 shells. So in the first shell, we have 2 electrons. In the second shell, we have 8 electrons. 1, 2, 3, 4, then 5, 6, 7, 8. And then in the third shell, we have 1 electron. So it means to say that the period that it belongs to, remember, periods go from left to right. Periods go from left to right. And it belongs to the third period. So not the first one, not the second one, the third one. And then we need to figure out which group it belongs to. We need to look at the valence shell. Now the valence shell is the outermost shell. The outermost shell has 1 electron in it. So that tells us which group it belongs to. If it had 2 electrons in this outermost shell, it would belong to group 2. If it had 4 electrons in this outermost shell, it belongs to group 4, and so on. So the outermost shell, the number of electrons in it, tells us which group this element belongs to. So it belongs to period 3, group 1. So period 3, group 1, this is C. C is your answer. C as in cat is your answer. Period 3, group 1. All right, so we're on to the next question. Question 10. Item 10 refers to the following information. When a compound is treated with concentrated hydrochloric acid, a greenish yellow gas, which bleaches moist red litmus paper, is given off. Now, and when we start talking about a greenish yellowish gas, we are talking about chlorine gas. Chlorine gas is normally a greenish yellowish gas. If we were dealing with ammonia, ammonia gas gives off a pungent odor. Sulfur dioxide will not give you a greenish gas. It means to say the sulfate ion is present. Nitrogen dioxide, it means to say the nitrate ion is present. They will not give you a greenish yellow gas. So that leaves us with option A as our answer. Chlorine gas gives you a greenish yellow color. All right, so the answer is A as in apple. Number 11. So same prelude. When a compound is treated with concentrated hydrochloric acid, a greenish yellowish gas which bleaches moist red litmus paper is given off. The concentrated hydrochloric acid is acting as what? So we have to ask ourselves, is the acid acting as an acid? Most likely not. That don't make sense. The acid cannot act as an acid. It's already an acid. It don't need to act as an acid. Is the acid acting as a catalyst? No, it's not acting as a catalyst because it's not trying to speed up the rate of the reaction or slow down the rate of the reaction. So the question is it a reducing agent or oxidizing agent? All right, the concentrated hydrochloric acid is given off chlorine gas. So HCl is going to produce Cl2. Now here, chlorine has no charge because chlorine as Cl2 is a gas, which means to say that it's now in its atomic state. But chlorine in HCl has a negative charge, while hydrogen has a positive charge. So chlorine went from -1 to 0. It means to say that it gained an electron. If you remember, RIG, reduction is the gain in electrons. So the hydrochloric acid is acting as a reducing agent to reduce the chlorine ions from Cl- to Cl2. So therefore the answer should be C as in cat. It is acting as a reducing agent. Yes. All right, moving along, next question. Two solutions are to be mixed in order to demonstrate endothermic change. Which of the following techniques would be most appropriate? Now, basic rule when you're trying to figure out whether something is endothermic or exothermic, you should check temperature change in temperature, right? If the temperature gets colder, meaning the value decreases, so it instead of being 27, 28, 29, 30, it goes 27, 26, 25, 24, 23, 22, 21. It gets colder. It means to say that more energy is being absorbed from the surroundings and the solution, whatever it is is going to get cold, right? So if you feel the container that it is in, it would be very cold. It means to say that it is absorbing more energy than it is giving off. If we want to check to see if a reaction is exothermic, normally exothermic reactions are explosive. So they give off more energy than they absorb. So exothermic reactions are usually hot, right? And the temperature rises. So they say two solutions are to be mixed if you mix them together in order to demonstrate an endothermic change. So they're checking to see if the temperature drops and if the container gets cold. Which of the following techniques would be most appropriate? Taking mass readings? No, if you take the mass before and after, the mass would change to be the same. Taking temperature readings, most likely. Monitoring the pH of the solutions? No, the pH does not affect whether it's endothermic or exothermic. Carefully observing color changes. The color change does not tell us whether it's endothermic or exothermic. So the answer that is left is B as in boy. B as in boy. Taking temperature readings is what's going to tell us whether it's an endothermic or exothermic change. All right, next question. Crystals of sodium chloride are best described as, so sodium is a metal, and chlorine is a non-metal. So we have sodium, this is a metal, and chlorine is a non-metal. When a metal binds with a non-metal, we're supposed to have ionic bonding. When a metal binds with a non-metal, we have ionic bonding. For us to have metallic bonding, it means to say a metal has to bind with another metal. So if sodium was to bind to sodium, we will have metallic bonding. If we had molecular bonding, it means we're dealing with molecules, right? So something like water, H2O, bonded to another H2O molecule, bonded to another H2O molecule. You have water molecules. This is molecular. And if we had something that is macromolecular, it means to say that that's a very strong bond. So we're looking at something like diamond, where we have carbon bonded to carbon, bonded to carbon, bonded to carbon. And it's a very strong structure. And each carbon is bonded to 4 other carbons. And this here is a macromolecular structure. But it didn't ask us for all of that. So which means that B, C, and D are all incorrect, and that leaves us with A as our option, ionic bonding. All right, so sodium chloride, it forms a lattice crystal. For each chlorine, it's bonded to a sodium ion, which is bonded to a chlorine ion, which is bonded to a sodium ion, which is bonded to a chlorine ion, which is bonded to a sodium ion, and so on interchangeably. So chlorine is bonded to sodium. So if you were to look at the actual structure, it looks something like this. And this is your salt crystals that you sprinkle on your food to give it some sort of flavor. So the answer to our question is A, type of bonding we expect is ionic bonding. All right, so next question. Ethanoic acid reacts with ethanol to form an ester and water. And that makes sense. An acid plus an alcohol gives us an ester plus water. How many moles of ethanoic acid are required to produce 0.5 moles of the ester? You say, well, sir, how do you expect me to know that? I never do no calculations for this. And I don't understand how they come up with them values. I supposed to what? Just say eeny, meeny, miny, mo? No, you're not supposed to do that. In fact, what you're supposed to realize is that 1 mole of the acid reacts with 1 mole of the alcohol to give you 1 mole of the ester and 1 mole of the water. He says, sir, what you're talking about? It's like if we were to actually display this reaction, this is example of, this is ethanol here. And ethanol is reacting with ethanoic acid, which is what they said. When the ethanol reacts with the ethanoic acid, 1 mole of this is reacting with 1 mole of this. If it was 2 moles, you would have seen 2 of these structures here. You'd have seen this structure times 2, right? And if it was 2 of this, you'd have seen this structure times 2. But it's 1 mole of this with 1 mole of that to give us 1 mole of the ester plus 1 mole of the water. So if we were to put it down in the displayed, the condensed formula, there's a 1 understood in front of each of these structures. So you say, so what is the significance of these values? 1 mole of ethanol reacts with 1 mole of the ester. Well, produces 1 mole of the ester. So let's go back to the question. If I have 10 moles of alcohol, then it's supposed to produce 10 moles of ester once it reacts with 10 moles of acid. So if I have 0.5 moles of the ester, then it means to say that I'm supposed to have the same amount of moles of the acid, of the alcohol, and of the water. If I had 2 moles of the ester, I should have 2 moles of the alcohol, 2 moles of the acid, 2 moles of the ester. If I had 5 moles of the ester, then I also supposed to have 5 moles of the acid with 5 moles of the alcohol to give us 5 moles of the ester. And I think you're beginning to get the point. So what they're saying here, right? This question is not asking you to try and solve it, but it's asking you to recognize that there is a 1-to-1 ratio of reactants to products. So if the ester, which is one of your products, has 0.5 moles, then the reactants is supposed to also have 0.5. If on this side you had 1.0, then on this side you're also supposed to have 1.0. So if we look at our answer, that means to say that our answer should be B as in boy, 0.5 moles is required. So 0.5 moles of ethanoic acid, 0.5 moles of ethanol come together to give us 0.5 moles of the ester, right? So the answer should be B as in boy, 0.5. All right, next question. The diagram above represents the arrangement of atoms in, okay, so this one, I have some diagrams that I want to show you, right? And it would help you with your understanding as to why the answer is the answer. So diamond is a giant molecular structure. And I was telling you that 1 carbon is connected to another carbon that is connected to 4 other carbons. So each one is connected to 4 other carbons, right? So if you check, this carbon has 1, 2, 3, 4, and this one would also have 1, 2, 3, 4. And the structure becomes very, very strong and sturdy, right? And it begins to look something like this. And it's like, oh, what's the significance of that? It's because of this type of bonding that it makes diamond very strong. That's why diamond can be used to cut glass and for many other purposes. This structure, however, is representative of that of graphite. Graphite in its molten state, it's able, the layers, there are weak van der Waals forces between this layer and the second layer and the third layer and the fourth layer and so on. Because of those weak van der Waals forces, they can slide over each other, right? So that is representative of graphite. Now, mind you, diamond and graphite are made from the same substance, carbon. They are made up of the same thing, carbon. However, with diamond, each carbon is connected to 4 other carbons, while in graphite, each carbon is connected to 3 other carbons, right? Each one is connected to 3 others. So if you were to look at this one here, it's bonded 1, 2, 3. Each one is connected to 3 others, right? 1, 2, 3. So there is one that is free. Now, if we look at the structure of benzene, benzene is a ring structure, right? There are different ways in which they represent benzene. Some books use this version, other books use that version, and some represent it like this. So if you see a structure like this, it only means to say that you're looking at a benzene ring. What does this mean? That inside of the ring, you see there's a double line here, a double line here, and a double line there. That tells you that there are 3 double bonds inside of the structure. All right, there are 3 double bonds inside of the structure. When you draw this circle, it just means to say that the double lines alternate. So they may not be in a fixed position all the time. They alternate from one position to the next inside of the ring. So this here is representative of benzene, right? Any one of these structures is representative of benzene. And if we were to look at the structure of sulfur, S8, it means to say that sulfur is normally represented, or it normally looks like this if you're looking at it from above. And then you have, this is from above, and then this is a side view if you're looking at it side on. So with that in mind, let's go back to the question. This structure above, the diagram above represents the arrangement of atoms in, and now you understand that it's graphite. So the answer to 15 is B as in boy. B as in boy. All right, so questions on that so far? Any questions, or are we good to go? No questions so far. All right, so I'm going to give you another 15 minutes to attempt from question 16 to 30, and then I will go through the next 15 questions with you. You okay with that? Okay, wonderful. All right, so I want you to take the next 15 minutes and attempt the next 15 questions with me. All right. Okay. So what we have done so far, 16, I said the answer is A as in apple. All right, in case you missed it, 16, the answer is A as in apple. All right, it has no effect on the yield of the products. 17, the answer is B as in boy. When hydrogen is with metal, hydrogen has a negative oxidation number. When hydrogen is with a metal, it has a negative oxidation number. All right, in case you missed it. Question 18. From which of the following substances can a solid be obtained by the process of sedimentation? From which of the following substances can a solid be obtained by the process of sedimentation? All right, gels, no. Emulsions, no. Foams, no. If you have suspensions, when the suspensions settle, it can give you a solid. All right, when the suspensions settle, it can give you a solid. So the answer I would put for this one is D as in dog, suspensions. All right, because of the word sedimentation, it means to say that there are substances that settle to the bottom. Right? If we have an emulsion is like fats dissolved in water. If we have a gel, it doesn't necessarily mean that it's a solid. And foam is like from when the soap ladder get a foam forming, doesn't necessarily mean you have a solid. But with suspensions, definitely you'll get a solid forming from that. So the answer for 18 is D as in dog, suspensions. Question 19. Which of the following gases show no reaction with moist litmus paper? Which of the following gases show no reaction with moist litmus paper. You can't use litmus paper to test hydrogen, right? You will not get any reaction, right? With ammonia, you could get a reaction because ammonia is a basic gas. With sulfur dioxide and hydrogen sulfide, you could get a reaction. You're dealing with acidic gases and basic gases, but hydrogen will give no reaction with litmus paper. So the answer for this one is B as in boy. B as in boy. Question 20. Which of the following techniques or processes may be used to separate a mixture of plant pigments? Plant pigments, we're looking at paper chromatography. Right? If we're trying to separate plant pigmentation, paper chromatography, right? The different pigments would separate because different colors dissolve at different rates. And on a chromatogram, they would move up the chromatogram at different rates, causing them to separate, thereby separating the plant pigments. So paper chromatography is the most likely option. Centrifugation is something, a centrifuge is something that spins very quickly at high speeds. That can separate something like a liquid that have different things dissolved in it. So for example, your blood, it could be separated by centrifugation, right? Solvent extraction, no, that would not work. And fractional distillation, that would be an incorrect process to separate it. So the answer for question 20 is D as in dog, paper chromatography. Question 21. A solution of iron 2 sulfate was added until in excess to a solution of barium nitrate. The precipitate produced was filtered off and water was added to the residue in the filter paper. All right, so now anytime we add water to residue, it's most likely to wash the residue. All right, anytime we add water to the residue, it's most likely to wash the residue. So you have iron sulfate was added until in excess to barium nitrate, right? Most likely you'll get a white precipitate from this reaction. So the question, the color of the precipitate produced was a white precipitate. A white precipitate is what was produced. The answer D as in dog. Next part of the question. Water was added to the residue to purify the precipitate. They'll add water to purify the precipitate. It's not to dissolve the precipitate. It's not to prevent further reactions. It's not to dilute the filtrate. All right, so Dimitri, when I finish here, I will talk to you, right? When I finish here, we have a conversation. It's not to purify the precipitate. Sorry, the answer is C, to purify the precipitate. C as in cat, to purify the precipitate. All right, question 23. The atoms of element Y contain 19 electrons. The chemistry of element Y will be similar to, it contains 19 electrons. There are 2 electrons in the first shell, 8 electrons in the second shell, 8 electrons, 2 and 8 is 10 and 8 is 18 and 1 is 19. So it have 1 electron in the outermost shell. So the atoms of element Y contains 19 electrons, okay? The chemistry of element Y will be similar to aluminum, magnesium, bromine, lithium. Aluminum is 10, 11, 12, 13, so that is 2, 8, 3. So it will not be aluminum. Magnesium is 2, 8, 2. So it would not be magnesium. Bromine is below chlorine, so that will have 7 in its outermost shell. So it can't be bromine. So it's lithium, which is 2, 1. 2,1 is similar to 2,881. It have 1 electron in the outermost shell. So the answer is D as in dog, lithium. D as in dog, which is lithium. All right. Which of the following halogens is a liquid at room temperature? Which of the following halogens is a liquid at room temperature? All right. Fluorine is a gas. Chlorine is a gas. Bromine is a liquid. Iodine is a solid. So the answer would be C. Bromine would be a liquid at room temperature. C. Bromine is a liquid at room temperature. During the reactions between ethanol and ethanoic acid, a small quantity of concentrated sulfuric acid is added. During the reaction between ethanol and ethanoic acid, a small quantity of concentrated sulfuric acid is added. So it is added to do one out of the 4 things. Oxidize the ethanol? No, it's not added to oxidize. Catalyze the reaction? No, it's not added to catalyze the reaction. Dehydrate the ethanol? I believe it's added to dehydrate the ethanol. Hydrolyze the products, dehydrate the ethanol. By dehydrating the ethanol, you allow for the formation of the ester, because remember, an alcohol plus an acid gives you the ester, right? And from the alcohol, the hydrogen is lost, and from the acid, the OH group is lost, which means to say water is lost to form the ester. So it means to say that the ethanol would have been dehydrated. So the answer to this question is C as in cat. It would have been dehydrated. All right, question 26. Which of the following reactions occur between propene and bromine? So propene is an alkene, so met, et, prop is an alkene, and that is reacting with bromine, which is Br2. What is going to happen? This double bond is going to break, and bromine is going to be added across the double bond. The double bond is going to break, and bromine is going to be added across the double bond. So that type of reaction is a addition reaction. They asked this question earlier, but instead of using bromine, they used chlorine. This time they have replaced ethene with propene, and they replaced bromine with chlorine. But the same principle applies. It's an addition reaction. So the answer for this question is A as in apple. Question 27. Iron chloride, FeCl2, and FeCl3 are 2 chlorides of iron. Which of the following statements about these 2 chlorides of iron is or are true? So 1, the percentage of iron by mass in the 2 chlorides is different. That is correct. The percentage of chlorine in FeCl2 would be different to the percentage of chlorine in FeCl3 because the numbers are the same. Yes, definitely. So something that have 1 in it is one of the answers. Next, in the color of the aqueous solutions of the 2 chlorides are different. That is correct. FeCl2 and FeCl3 would be different because iron, Fe2 plus and Fe3 plus, would have 2 different colors, right? And thereby, it means to say that by extension, the chlorine in it would also be given off a different color. So the 2 chlorides will have different colors. So that is true. 1 and 2 is correct. 1 is iron, Fe2 plus is, I think, is green, and Fe3 plus is brown. If you're trying to remember it, just remember that Fe3 plus, that's when, so for example, think of your banana. When you leave your banana exposed to the atmosphere, right, it's the banana skin goes to brown, right? That is because of the presence of iron in it. The same thing happens with your apple, right? When they cut the apple, if you leave it exposed to the atmosphere, it goes to brown because the ion inside of the apple moves from Fe2 plus to Fe3 plus. For the part 3, the aqueous solution of the two chlorides do not conduct electricity. Iron is metal, so it most likely will be conducting electricity. So I will not be supporting 3. So my answer is 1 and 2 only, C as in cat. I would say the answer is C as in cat, 1 and 2 only. When solid lead nitrate is heated, it decomposes, giving off nitrogen 4 oxide and oxygen. The balanced equation for this reaction is, so we're looking for one of these equations where the same amount of reactants is equal to the same amount of products. So on this side we have 2 lead, over here we have 2 lead. On this side we have nitrogen by 2. On this side we have 4 nitrogen. But this nitrogen by 2, there's also a 2 in front here. So 2 by 2 is 4. So we have 4 nitrogens. So that is accounted for. That is accounted for. So now we need to check the oxygens. We have 2 3s are 6 oxygens. And that's 6 by 2, which is 12. So we need to find 12 oxygens. So on this side here, we have 2 oxygens because of the 2 in front here. Over here, we have 4 2s are 8 oxygens because of the 4 in front here. And then we have 2 oxygens. So 8 and 2 is 10 and 2 is 12. So we have the 12 oxygens over here and 12 oxygens here, 2 lead and 2 and 4 nitrogens. So this equation to the top here is balanced. So the answer is most likely this answer, this option A. In option B, we have 1 lead, 1 lead. We have 2 3s are 6 oxygen and 2 nitrogens. So we have lead 1, oxygen 2 2s are 4, 2 here, 2 here, and 1. So we have 5 oxygen and 6 oxygen over here. So this is not balanced. This one lead, 1 lead, 1 lead. We have 2 3s are 6 oxygen, 2 2s are 4, and 1 is 5 oxygen. Sorry, 2 2s are 4 oxygen, and 2 6 and 1 is 7 oxygen. We have 7 oxygens on this side and we have 6 oxygens on this side. This is not balanced. With this one, we have 2 leads over here and we have 1 lead over here. Again, this is not balanced. So that leaves us with A as the answer. A as an apple is the correct answer. Question 29. Which of the following compounds yields a brown gas and a black solid residue on heating? All right, well, this one I think might have given you a little challenge, but the answer should be copper nitrate. When copper nitrate is heated, it becomes dehydrated because water is being removed from it. After that, what begins to develop is a brown gas begins to develop, and then a black solid residue is given off from it. So the answer should be D as in dog, copper nitrate. In question 30, which of the following metals are extracted from their ores by reduction of their oxides with carbon? Which of the following metals are extracted from their ores by reduction of their oxides? So we're looking at something like either reduction of the oxides. So we're looking at a process like using the blast furnace. So something like iron oxide, hematite, Fe2O3. or zinc oxide, right? So iron or zinc. If we were talking about aluminum, aluminum would have been using hydrolysis, right? So it's not aluminum. So the answer to this is iron and zinc, D as in dog, right? We normally extract them from the ores and we use carbon to do that, right? We use carbon, we normally call it coke. We use carbon to extract iron and zinc from the ore. So the answer to 30 is D as in dog. All right. So any questions from 16 to 30? All right, check and see how much you're getting right and wrong, right? Because at the end, I want you to send me a little message to tell me how much you get right and how much you get wrong. No cheating, eh? All right, so I want you to attempt questions 31 to 45 for me now. All right, you're going to attempt question 31 to 45. I think we might run out of time if I let you do that. All right, let us do 31 to 45 together, just to ensure that we don't run out of time. All right, all right, so we're going on to question 31. And question 31 reads as follows. During the electrolysis of aqueous copper to sulfate solution using inert electrodes, the ions migrating to the cathode are, so cathode, cations, anode, anions. All right, cathode, cations, anode, anions. So the electrolysis of aqueous copper to sulfate. So if you have aqueous copper to sulfate, aqueous means it's dissolved in water. Water is made up of H plus ions and OH minus ions. And the copper sulfate is made up of copper ions and SO4 2 minus ions. So these are the 4 ions that we have in the solution. So at the cathode, it would be attracting cations, which are positive ions. Our positive ions are Cu2 plus and H plus. So we're looking for Cu2 plus and H plus. So the answer to this question is A as in apple. All right, so I didn't have to know everything. All I needed to know that this was aqueous copper 2 sulfate. And from that, I identified all the ions present. Then I checked to see what is attracted to the cathode, what is attracted to the anode. And then from that, I could figure out which ions go to the cathode and which ions go to the anode. So the answer to 31 is A as in apple. All right, so next question, question 32. 32 refers to the following diagrams, which represents bonding as it occurs in certain compounds. So here in this structure, they're sharing 1 electron. So this structure is sharing 1 electron with this structure. Here, this structure is sharing 2 electrons with this structure. Here, this structure is sharing 3 electrons with this structure. And here, 2 of the same things are sharing the same amount, 1 electron with each other. A is different from 2 different electrons because this one have 1, 2, 3, 4, 5, 6 electrons in the outermost shell, while this one only have 1 electron that is in the outermost shell that it's sharing. all right? And D has the same amount of electrons in the outermost shell, and they are sharing an electron. So the question is, which of the diagrams illustrate bonding in chlorine, right? Which of the diagrams illustrates bonding in chlorine? Chlorine is element 17. So therefore, it has 2 electrons in the first shell, 8 electrons in the second shell, and 7 electrons in the outermost shell. So we're looking for 2 structures that have 7 electrons in the outermost shell. And in order for this second shell to be filled, it would need 1 electron. So they have to share 1 electron to become stable. So we're looking for 2 structures that have 7 electrons in the outermost shell where they're sharing 1 electron. So you have 1, 2, 3, 4, 5, 6, 7, and then you have 1, 2, 3, 4, 5, 6, 7. So D, they're sharing the electrons, they're sharing the electrons to become stable. This structure is representative of bonding in chlorine. So the answer to this question is D as in dog, right? Covalent bonding, because the valence shell requires 1 electron to become filled. Next question. All right, the same diagram, which of the diagrams illustrates bonding in oxygen? So let's check oxygen. Oxygen, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Oxygen is 8, so that means it has 2 electrons in the first shell and 6 electrons in the second shell. So how much electrons is needed to make the outermost shell stable? 6 plus 2 more electrons would make it stable, because this second shell could hold up to 8 electrons. If we check to see, we're looking for something that is sharing 2 electrons each, right? 2 structures that are sharing 2 electrons. So A is not sharing 2 electrons each, but B, there are 2 circles and 2 dots, well, 2 X's being shared by either atom. So that means to say that this structure is representative of oxygen, because oxygen needs 2 electrons to become stable. So if I have 2 oxygen molecules, it means to say that both oxygen atoms need to share 2 electrons for both oxygens to become stable. So they have to both share 2 electrons. So the answer to this question, 33, what diagram illustrates bonding in oxygen? It would be B as in boy. That's illustrating. It's still covalent bonding because it's 2 non-metals, but just that they're sharing 2 electrons, because the outermost shell requires 2 electrons to become filled for each oxygen atom. Next question. Question 34. The rate of a chemical reaction does not depend on the presence of a catalyst. Yes, that would speed up the rate of a reaction. The concentration of the reactant. Yes, that will affect the rate of the reaction. Temperature of the system. Yes, that will affect the reaction. Energy change associated with the reaction. No, that will not affect affect the rate of the reaction. However, a change, it's just a matter of when. So rate has to do with time. The energy change will be the same no matter whether it happens fast or slow. All right, so the answer to 34 is D as in dog. The answer to question 34 is D as in dog. 35. 35 to 36 refers to the following reactions. You have hydrolysis, dehydration, saponification, and esterification. Saponification is the making of soaps. Esterification is the making of ester. Dehydration is the loss of a molecule. Most times it's water. Hydrolysis is it's splitting by water, or splitting because of water. So in which reaction is ethane produced from ethanol? In which reaction is ethane produced from ethanol? In order for us to get an alkane from the alcohol, water has to be lost. So we are dealing with a dehydration reaction. If we dehydrate the ethanol, we will get back the alkane. The alcohol goes back to the alkane if it is dehydrated. Right? So if you have ethanol, met, et, OH. Right? If you were to remove water from this structure, you can get back, if you were to remove water from this structure, the OH, if you were to remove it from the structure, you can get back the alkane. Right? So dehydration reaction is what is your answer for this question. So 35 is B as in boy. Next question. 36. Which reaction involves the boiling of a fat or oil with aqueous sodium hydroxide, which is caustic soda? This here has to do with saponification. They use fats and oils to produce soap, right? They react the fat or the oil with sodium hydroxide, and that gives you the salt of the acid, right? So you end up with the formation of a soap, right? And the soap is an ester because there's an ester linkage that is present. So the answer to this question, which one reacts, involves the boiling of a fat or oil with aqueous sodium hydroxide? And the answer to this is saponification, the making of soap, right? Next question. Item 37 to 38 refers to the following acids. You have sulfuric acid, hydrochloric acid, nitric acid, and ethanoic acid. In answering item 37 to 38, a particular acid may be used once, more than once, or not at all. Which acid functions as a dehydrating agent when it is concentrated? Sulfuric acid. Sulfuric acid tends to behave as a dehydrating agent when it is concentrated. How so? Is because it can draw or pull out OH groups from other substances to form water. Sulfuric acid, there are a lot of H plus ions, and OH ions can come and bond with it. So sulfuric acid tend to act as a dehydrated agent more than the other acids present when it is concentrated. So the answer to 37 is A as in apple. 38, which acid reacts with copper to produce an acidic red-brown gas? Nitric acid. Nitric acid produces a reddish-brown gas, right? When it reacts with copper, it tends to produce a reddish-brown gas, and that is nitric acid. Right? Nitric acid produces a reddish-brown gas. So the answer to this one, 38, is C as in cat. So 38, C as in cat. 37 is A as in apple. All right. So next question. 39. Which of the following ionic equations involves oxidation? Now, if you remember, oxidation is the loss in electrons, OIL, loss in electrons. So if we look at the first option A, we have S is 2 minus, minus 2 electrons to give you S atom. So there's no charge here, but then there's a charge over here. So S went from -2 to 0. So it means to say that it would have gained 2 electrons to become 0. Which of the following ionic equations involve oxidation? All right. So let's look at chlorine. Chlorine went from Cl0 without a charge, and it went to -1. So chlorine went from 0 to -1. This went from -2 to 0. This one, hydrogen, went from +1 to 0. And sodium went from +1 to 0. All right. So they ask, which of the following ionic equations involve oxidation? Well, C and D is the same thing. So C and D is most likely out. All right. So that leaves us with A and B as options. A and B as options. So B, oxidation is the loss in electrons. So if we lost an electron, something becomes positively charged. So if an electron, so to go from 0, -1, -2, -3, and 0, +1, +2, +3. All right, so this is your number line, as you know it, right? Your number line. So if I have a substance that gains an electron, it becomes -1 because it would have moved from 0 to -1. That means it gained an electron. If something lost an electron, it means to say that it will become more positive. So sulfur lost 2 electrons. So it went from -2 to 0. So it was becoming more positive. So the answer to this question is A as in apple. Sulfur went from -2 to 0. It lost 2 electrons, so it became more positive. Oxidation is the loss in electrons. So the answer is A as in apple. All right, oxidation is the loss in electrons or the gain in oxygen. All right, question 40. Which of the following methods is used for the extraction of aluminum? The extraction of aluminum? Oh, well, electrolysis of molten oxide, of course. The answer is A as in apple. Reduction of its oxide using coke? No, that is for iron and for zinc. Electrolysis of its aqueous chloride? No, that has nothing to do with it. The reduction of its oxide using carbon monoxide? No, carbon, the only time we use coke is when we're dealing with iron and we're dealing with zinc. So it's electrolysis of its molten oxide. The answer is A as in apple. Question 41. They show you three structures Q, R, and S. Three structures Q, R, and S. Which of the following correctly identifies the homologous series to which each compound belongs? So this here, the functional group is C double bond O, OH. That's an acid group. Here, the functional group is C double bond O, O. That's the ester group. And here, the functional group is OH. That's the alcohol. So we're going from acid to ester to alcohol. We're looking ester alcohol, acid alcohol, A is out. Acid alcohol, ester, B is out. Alcohol, ester, acid, C is out. Acid, ester, alcohol. The answer is D as in dog. All right, D as in dog is your answer. Acid, ester, alcohol, in that order. Next question. Which of the following metals neither react with water nor displaces hydrogen from dilute hydrochloric acid? We're looking for something that is below hydrogen in the reactivity series. Which of the following metals neither reacts with water nor displaces hydrogen? So if something is not displacing hydrogen, it has to be below hydrogen. Zinc is above hydrogen, iron is above hydrogen, calcium is above hydrogen. So that leaves us with copper. Copper is the answer. The answer is C as in cat. Right? Copper is below hydrogen in the reactivity series. So therefore, those that are higher up, those that are higher up in the reactivity series are given preference to those that are lower down in the reactivity series. 43. The existence of millions of organic compounds is due primarily to the ability of carbon to form one, multiple bonds. Yes, carbon could form multiple bonds. You could have single bonds. You could have double bonds and you could have triple bonds, okay? Ring structures, yes, you have the benzene ring, if you could remember, the benzene ring. You have cyclohexane, right? You have structures like glucose, they have ring structures present in it. So yes, and they are organic compounds. The ability to form branch chains, yes, you can form branch chains. So you could have a long carbon chain, but connected to the carbon chain is another chain. And connected to another carbon is another chain, and so on and so on. So yes, you can have branch chains. So the existence of million organic compounds is due primarily to the ability of all these three things. Because of these three properties, you're able to form organic compounds. So I would say the answer is D, 1, 2, and 3. They all contribute to the diversity of organic compounds that we have. (44) Which of the following aqueous solutions will produce a yellow precipitate with aqueous potassium iodide, lead nitrate? Lead nitrate would produce a yellow precipitate with aqueous potassium iodide. Right? Not zinc sulfate, not calcium chloride, not sodium carbonate. When you have carbonate, most times it gives you a white precipitate. When you deal with calcium, it also gives you a white precipitate. And zinc can tend to give you a white precipitate as well, right? But with lead nitrate, lead is characteristic. Once iodine is present and you're dealing with lead, you would end up with a yellow precipitate. So the answer is A, as in apple. All right, question 45. It was found that magnesium metal displaces zinc ion in zinc sulfate. Which zinc metal displaces lead ions in lead sulfate? Sorry, while zinc metal displaces lead ions in lead sulfate. Question 45. What is the order of reactivity from most reactive to least reactive metal? Okay, so it goes magnesium, zinc, and then lead. Lead, zinc, magnesium, no. Zinc, magnesium, lead, no. Zinc, lead, magnesium. So magnesium is more reactive than zinc, which is more reactive than lead. So the answer is B as in boy. Right? So all you need to do is look at your reactivity series and you would know that this one is the answer. Magnesium, zinc, and then lead. All right, so the answer to that question was B as in boy. All right, so 46. Items 46 to 47 refers to the following organic compounds. You have natural gas, propene, ethanol, and vinegar. In answering items 46 to 47, each compound may be used once, more than once, or not at all. All right, so I want you guys to help me answer these questions from 46 to 60 and see how fast you can get through it. Okay, so which of the compounds can be hydrated? Now, when we say something is hydrated, we mean we add water to it. When you're dehydrated, you're lacking in water. When it's hydrated, you add in water to it. So 46, which of the compounds you think can be hydrated? Any ideas? All right, I'm not seeing anybody giving any ideas. So I'll tell you. So if we have ethanol, an alcohol can undergo oxidation to produce an acid. Right? Vinegar is an acid, but here we have ethanol, which is an alcohol. So if we were to hydrate the ethanol, it can move on to become an acid. Right? And that will happen by way of oxidation. So the answer to 46 is ethanol. C as in cat. Ethanol can be hydrated. 47. Which of the compounds has a pH that is less than 7? So if something has a pH less than 7, we're looking for something that is acid. All right, so A, B, C, or D, which one you think is an acid? All right, D as in dog. Yes, that's correct. Vinegar? Vinegar is acetic acid. So yes, the answer is D as in dog. Vinegar has a pH that's less than 7. That is correct. 48. Which of the following is produced when carbon monoxide reacts with iron trioxide? So that is Fe2O3. We have iron oxide, and it's reacting with carbon monoxide. So what is going to be produced? It will be carbon dioxide and iron from this one. When carbon monoxide reacts with it, from the iron trioxide, Fe3O2, we will end up with carbon dioxide and iron. So the answer should be D as in dog from this one. So 48, the answer is D. You'll end up with carbon dioxide and iron. 49. A piece of limestone is treated with dilute hydrochloric acid. Which of the following would be observed? All right. Limestone dealing with dilute hydrochloric acid, carbon dioxide gas is given off, so you'll end up with effervescence. Yes. A gas is evolved with a pungent odor. Yes. You could also have the evolution of chlorine gas. A gas is evolved which turns lime water milky. Yes. That is the carbon dioxide given off. So my answer 1, 2, and 3. The answer is D as in dog. 1, 2, and 3, D as in dog. Wait, no. Just a minute. I need to verify that that is the correct thing. $49. Okay, I just want to check one thing. No. Okay, sorry about that. Okay, so back here. Okay, no, the answer, it can be B. D as in dog. Carbon dioxide gas does not have a pungent odor. So the answer should be 1 and 3, not 1, 2, and 3. The answer should be B as in boy and not D as in dog. B as in boy and not D as in dog. Right? Because carbon dioxide gas doesn't have a pungent odor. Right? It's not like ammonia. Right? So the answer is 1 and 3, B as in boy. Right? So it's not 1, 2, and 3. It's 1 and 3 only. So the answer is B as in boy. All right. So last 10 questions, guys. Let's see how fast we can get through it. Question 50. Which of the following structures represents a compound that can react with an alcohol to produce a sweet smelling liquid? All right, so which of the following structures represents a compound that can react with an alcohol to produce a sweet smelling liquid. And when we have a sweet smelling liquid, we are talking about esters. Esters are sweet smelling, right? So the answer to this, we're looking for something that have an ester. A is an alkene, so it's not A. B is an alcohol, so it's not B. C is an acid, no. Yes. C is an acid. An alcohol plus an acid will give you an ester. So the answer is most likely C as in cat, and D is an ester. An ester wouldn't react with the alcohol to give you an ester. So the answer is C as in cat. An acid plus an alcohol would produce a sweet smelling ester. The answer is C as in cat. All right, next one. Steel is often used in place of iron because it is stronger. Is more susceptible to corrosion? No. It has a lower melting point? No. It is cheaper? No, because it's stronger. Right? Most times we use steel over just pure iron, because by merging other like stainless steel, by creating an alloy, we reinforce the iron and we make it stronger. So the answer for this one is C as in cat. Yes, because it's stronger. All right, 52. A solution has a pH of 1, so which means to say we're talking about something that is acidic, right? This solution would be expected to react with an acid plus a metal will give you hydrogen gas, a salt and hydrogen gas, A as in apple. So this solution would be expected to react with zinc, which is a metal, to produce hydrogen gas. So the answer for 52 is A as in apple. Right? How do I know that? If it has a pH of 1, we're dealing with an acid. And when an acid reacts with a metal, it produces a salt and hydrogen gas. All right, next one. Which of the following is the reason for adding cryolite to pure alumina in the extraction of aluminum by electrolysis? And by adding cryolite, we lower the melting point, right? Which makes it easier to extract aluminum from its ore, right? From aluminum oxide. So it lowers the melting point. Okay, I don't know what just happened there. All right, just a minute. All right, so yes, it lowers the melting point. So you say, what type of reaction occurs when zinc metal is added to copper sulfate solution? When zinc metal is added to copper sulfate solution, you have a displacement reaction. Because of the two metals, the one that is higher up in the reactivity series will displace the metal that is lower in the reactivity series. So the zinc metal is going to displace the copper metal, and instead of having copper sulfate, we will end up with zinc sulfate. So we'll have a displacement reaction. So the answer will be C as in cat. Next question. A formula of a gas with a distinctive color, nitrogen dioxide, NO2. All right, a brown gas is given off nitrogen dioxide, NO2, is very distinctive. The answer is B as in boy. All right, 56. Which of the following is a natural source of hydrocarbons? Which of the following is a natural source of hydrocarbons? Petroleum is a natural source of hydrocarbons. Some people have attempted to say methane, but the answer is D. Your most correct answer is D. There are two right answers, methane as well as petroleum. But the key to it is they say natural source. Petroleum is naturally occurring. Methane gas is a gas that is produced as a result of reactions taking place. So for example, from the cow, from the landfill, you could have a lot of methane gas produced, but petroleum exists in the Earth's core. So the answer to 56 is D as in dog. All right. Question 57. Last three, guys. All members of a homologous series have similar chemical properties. All members of a homologous series have similar chemical properties. So the answer should be C as in cat. All members of a homologous series have similar chemical properties. The answer, C as in cat. 58. Glucose is converted to starch or cellulose by condensation polymerization. Glucose is converted to starch. Glucose is a monomer and starch is a polymer of glucose. Cellulose is a polymer of glucose. Many glucose units make up starch. Many glucose units make up cellulose. So condensation polymerization is what is needed to convert glucose to starch. Condensation polymerization, because water is removed during the process, and we end up having the formation of what is called glycosidic bonds. You're not required to know what the glycosidic bond is, but as what is formed between the glucose molecule. So the answer to this question is A as in apple, condensation polymerization. All right, two more, guys. 59. Which of these compounds will react with bromine solution only if light is present? Alkane. So we're looking for an alkane. C2H2, that's not an alkane. C2H4, that's not an alkane. C2H6, that's an alkane. So the answer is C as in cat. C4H8, that is not an alkane. This is an alkene, an alkene, and an alkyne. So the answer is C as in cat. C2H6, which is an alkane. Alkanes react with bromine in the presence of UV light. So the answer is C as in cat. And last one, guys. During the manufacture of ethanol by fermentation, the gas evolved does what? So you need to figure out what gas is evolved and what would it do. The gas that is given off is carbon dioxide gas. And carbon dioxide gas, it does not burn with a blue flame. It does not relight a glowing splint. It does not turn potassium dichromate green. It turns lime water cloudy. So your answer to this one is B as in boy. It turns lime water cloudy. And ladies and gentlemen, that brings us to the end of this session and the answers to Jan 2017 CSEC paper all right, from 1 all the way down to 60. All right, so if you have any questions, please now take this time to pose the questions for me. If not, well, we just wrap up here and we'll call that a day for today.